All right, welcome back. So, doing a quick little kit today, a little bit of discussion. So, before we start the kit, just wanted to show you this is the next video I'm working on. I got this 1800 watt high-end inverter here that started getting an overload code, stopped working, and I'm gonna see if I can't repair it. So I don't want to give away the secret sauce here, but that's the next one that should be coming out. Alright, so with that out of the way, let's get into this Shaky Jake's kit. There we go, we're off to a fantastic start here. So, I had a lot of people talking about, well, there were some good ideas. Some people would talk about using Arduinos. I don't know, a lot of people, well, I guess not a lot, but it seemed excessive how many people wanted me to turn this into an Arduino project, my shifter I'm talking about. Which is kind of the whole point, is to just gain manual control and not make it a shifter, but yeah, whatever. So, there was some good ideas for the line pressure solenoid. That was, some people said use a servo tester, and then again there was other people wanting me to use an Arduino for the pulse width modulation control. But it's not so straightforward, you know. Those solenoids, usually they're around 5 ohms. They could be like 3 to 10 ohms. But, I mean, let's just say 5 ohms. If we're working 14 volts DC with the engine running, the alternator charging. So that's going to be almost 3 amps drawing on that solenoid. So I can't just hook up an Arduino right to the output. I mean, I can't just hook up the solenoid right to the output of Arduino and drive this 3 amp line pressure solenoid. So there is a little bit of designing that has to be done, and that is another video I'm working on. This is actually something I've looked into before. See, this is one of the drawers from my office downstairs. You see, I got a couple of pulse width modulation. These are 20 kilohertz motor drivers, and I got some MOSFET amplifier boards. And I'm sure you've seen in the background of my videos before. Downstairs, I have a bunch of 60 amp or 60 volt 30 amp MOSFETs and a few other things in boxes down there that I can use for the line pressure project. So that's another thing coming in the future. But for today, we're just assembling the Shaky Jakes kit. And I mean, if you're looking at this circuit board, it's not very complicated, but it's a cool it's a cool kit. I got this. I want to make this for my mom for Mother's Day. If I can see, here's the picture of what's going on here. It's just like a carnival game kind of deal, like Operation, but it's the crazy wire you bend yourself. I don't know if you guys have been on Electronic Goldmine, but that is a fantastic. That was one of the first sites. If you go way back on my channel, you'll see this video where I used to have a desktop computer that I built into a desk. This is back in 09, I think, and I had a key switch. There's a video on my channel back then where I turn a key and the computer starts off or the computer shuts down, and that was a Zenith key switch out of old cable boxes. And the Electronic Goldmine back in the day had gotten them all, had desoldered them all from these cable boxes that they got, and were selling just the C&K Zenith blocks. Sorry about that. Very cool. They do all kinds of stuff like that. You can get like crazy weird military surplus. Like they were selling Honeywell gyroscopes for a while a few years ago, and it's just I can't think of more good stuff right off the top of my head. But they got all kinds of cool stuff going on. And also, the reason I brought them up is because Cheney Electronics is a involved with them. I think it's like a same people, just two different companies keep things separate. Because Cheney is just the kits, and most of the stuff, probably not 100% of it, but most of it is sourced from the USA. I mean, look, he has a Mallory buzzer made in America, and there's a transistor there. Some other things, I'm not sure, but boards made in America. Love supporting the local economy when I can. Get enough stuff from China. So, I think that's plenty of rambling. Let's get down to assembling. Got my extractor fan going. This wire I'm not a huge fan of. I think I brought it. Well, what gauge do you think that is? That's smaller than I thought. That is might be in the 20s or 18. I don't know. So this is some superfine 28 gauge. I didn't realize. Maybe I'll use this instead. I was originally planning on using this stuff, but it's a little too thick, I'm thinking. I just like silicone wire. It's much more flexible and easier to handle. More freedom of movement. Alright, so let's get all these going. I'll go ahead and open the forbidden instructions. Just looking for a picture of the board, really. Oh. Yeah, that's not good enough. Well, stand this up in the background, I suppose. You guys can't really see. Here, let me show you real quick. So they get a little bit of instructions, quick little picture. It's only 6. What is that? 3? Yeah, 6 resistors, couple LEDs, switch, and the buzzer. Pretty straightforward stuff. I got a couple different soldering irons going, and I got my blowtorch so I can solder this heavier gauge wire without too much effort. Oh. Okay, so I am going to start. Oh, where did I say to start? LEDs, huh? Alright, sure. So, looks like this is going to be the buzzer right here. Oh. Whoops. So it looks like this is going to be the buzzer right here. And where's my... Oh, wait, did I just do the same... Whew. Alright. Let's try this again. It's weird that they don't have a schematic. Oh, it's a schematic. Yes. Okay. So those two are tied together. I see. Alright. Anyways. There's the flat side. There it is. So flat. Oops. So the flat side on LEDs is the negative. I can manipulate this thing properly. So this is. Oh, I'm such a fool. Getting carried away here. So this is the top of the board, obviously. I wouldn't, how would I solder if I was sticking them through that side? I wouldn't. Anyway, so there's the buzzer right there. Oops. There's L1. And what I was going to say is the flat side is the negative. So when you see in the instructions the black corner of the LED, that's the negative side. So down it goes. And go ahead and get this soldered in real quick so I can stop holding it. Yeah, it's funny. I forgot to. Usually I will mount my solder in one of the alligator clips, but I forgot to do that ahead of time. Well, that didn't take very well. Let's see what I got this set to. Oh, 3. Oh no, that should be fine. Let's see. Yeah, still not taking as good as I had anticipated. It's a little odd. Oh, wasting time on that. Clip these bad boys. I forgot to bring up my little recycling bin. That's usually where I put all my metal clippings from making circuits. Then I melt them down. It's another video I plan on making at some point. Too many projects, not enough time. Anyways, oh, they want, yeah, forgot there's 2 LEDs. And the other one is down here. Let's see. There is the transistor right there. And then this is the switch right here. So that means this is the LED right here. And these 2 holes. And I'm just trying to find the flat side. Hard to tell. If you can't find the flat side, just go by the shorter leg. Same thing. So that is in the correct direction. Go ahead and, oh, see, I forgot to do it again. There we go. Get my solder set up. Now, let's go ahead. Oh, this thing needs a good cleaning. Yeah, turn the temperature up a little bit too. From this side. Yeah, still, still not taking as I anticipated, but it's going. Oh yeah. A little better. Gotta keep your tip clean. Don't want that thing to rot away. Although, you know, most of my soldering iron tips are from China, so they rot away regardless of how clean you keep them. But that's neither here nor there. So, I don't know if I had mentioned I was looking. Got distracted, sorry. Anyway, so next step. We got the LEDs in. The next thing is resistors, and it says 1 through 6 per the color code and the parts layout. Wow, where is... here we go. So 1, 2, and 5, 820 ohms. These are 820 ohms right here. So when we look at this other picture, 1, 2 go above the buzzer. What did I say? 1, 2, and 5 are the 820s. So, oh, forgot to do that in front of the camera. So we'll give them a little bend. Oh, actually, I think I bent those too close. Let's see. Yeah. All right. Keep using the same method. Yeah, really, it depends on how I'm feeling onto how I end up You know, sometimes I'll hold the solder in my hand and I'll mount the board. You know, I got these pegs and the clamp. But other times, I prefer this method. Usually when I'm rushing, I prefer this method. Yeah, soldering in cars too. When I do it, like say I'm doing an injector and I'm trying to not take the intake off, you know, so you gotta like reach in because the intake does that L-shaped thing, and the injectors are under it. So I got my I'll solder up the tip of my soldering iron, stick the syringe in there, wet the connection, and then just feed the soldering iron in with the solder already on the tip, kind of like I'm doing now. So let's get this other 820 in there. So I got a few more kit live streams I plan on doing. I ended up getting well, I got an assortment. I got some American-made kits because I'd rather give my money to a fellow American, but the selection isn't all that great. So I got as many as I could, but China's got some really cool electronic kits. So I got a ultrasonic distance measuring kit, and then I was at this tool consignment store a little while ago, and the guy was selling these. Uh, God, I want to say they were from the 80s. They might have been early 90s, but they're infrared and ultrasonic distance measuring, and they do these crazy calculations. So you set it up to do the total volume of a room, and then it'll say, all right, do measurement 1, and you set them in each corner, and then you do measurement 2, and you do the other wall, and then it asks for measurement 3, and you do floor to ceiling, and it'll do the math for you. uh, and the problem is they don't work. I mean, nothing is obviously blown, but you put a battery in them and it doesn't do anything. So I'm assuming the caps are probably just dead, and maybe some other simple stuff. So, anyways, I got the both of them for $5, and so I want to do a live stream where I build that kit, and then later on I'll make the video trying to repair and use the distance measuring tools. That was a good idea. Shame, you know, all these ideas and no time to do them. Not that life, though. Anyways, so we got. Oh, we're still in the resistor stuff. I forgot. What was the third one? R5. R5 is directly below the buzzer. It's that gap right there. So let's put the last 820 across that gap. Oops. Oops. I got some bad camera etiquette here. There we go. Yeah, it's a shame. The video I did on the shifter I built, you know, I have so much more footage that I had filmed back when I installed the thing in the truck and was originally designing it, and I planned on having a much longer video going into much deeper detail, but I almost forgot the flex. But then I just never really had enough time to lay it all out, and the footage was scattered on different computers and phones, and so in the end I was like, I'll just make a quick rundown, because I had had a couple comments asking for an explanation that like a year prior, you know, so I was like, all right, I'll just make something quick and easy. And sure enough, that's the one that gets a bunch of attention. So it's like 100 comments asking me everything you could possibly think to ask. And of course, you know, 90% of the questions are all things that I wanted to put in the original video, and I just didn't have enough time. But it's the way she goes, isn't it? I'm just rambling. So anyways, that was the first half of the resistors. The second one is the 1Ks. That's R3, R6. These right here are the 1Ks. R3 and 6 are these gaps and this gap. Or I don't know why I said these. This gap and this gap. And stuff these puppies in there. Got my rhythm going. Next one down. Oh, I've already forgotten which. Oh, yeah, it's this one. And we went opposing up there, so I think I'm going to do opposing down here as well. This is 3 and 6, yeah. 1K. Yeah, the other thing, the other thing that's killing me is I had just taken my truck off the road a few months ago, and so it's kind of hard to. Now I want to make this video building the line pressure solenoid controller, but it's going to be a little difficult to. I'm going to have to re-register my truck and get it inspected and everything if I want to do some road tests. I do have like a mile-long dirt road on some private land I could drive on, but that's not really the full test. So, I don't know. I'm not sure what I'm going to do about that, because that's a video I want to make soon, but I've also got work I got to do in my car, too, and how life is. We'll see. Anyways, I don't know why I keep rambling about nonsense. Let's get this last resistor in here. So we can move on to some more exciting stuff. Yeah, really, almost forgot the flux again. Had a rhythm for a second, fell right out of it. So oh yeah, my plan for the, my plan for the transmission controller, the mainline pressure, the mainline pressure controller was just a MOSFET, N-channel MOSFET, driving the, being driven by pulse width modulation. So, after the resistors, this bad Larry in. I got it facing the wrong way. Oh, wait. Yeah. Just like that. The beveled edge and the face of the case. What side the label's on and what side the heatsink's on. A couple different ways you can tell. So, you get the flux going here. Yeah, that's pretty much, I prefer well, I don't know. I used to prefer using the flux paste, but using the syringe with the no clean flux is just so much faster and simpler. smoother, I suppose you could say. Yeah, I ended up buying it just as just something to try to see if it could make me go a little bit faster while working on cars. And it does. It made a huge difference. So I brought it home and started using it on kits. Oh, almost got a bridge there. And it just makes things, I don't know, it just makes the flow quicker, smoother, easier. Ah. Ah. Oh well. Gives it character. Actually, to be honest, I could probably, well, I guess that's a heat sink. I'm not going to cut that off. That would be silly. I mean, I can't imagine that the duty would be. Uh, we'll see. We'll see how it goes. Maybe I'll cut it off. I'll have to wait and see what the current draw and the dissipation is. Well, let's see. It's been about half an hour. I would say 15 minutes of that was me rambling about nonsense, and the rest was kit building. So we're doing pretty good. uh, let's see. What comes after? Oh, the buzzer. Doing things in their order. Got a Mallory Sun alert. Yeah, comment if you guys got any better electronic suppliers. Like besides, I'm not talking like Mauser and DigiKey and stuff. I mean like electronic goldmine is like I don't even know how to describe it. It's like a rummage sale of an electronic store. They get like they buy out buildings that close down and lots of electronic components. Just totally random things. Like I bought military fuse holders that like light up when the fuse is blown, and I mentioned that they had the um, gyroscopes, Honeywell gyroscopes, and all kinds of crazy stuff. So I like checking them out, but I can't think of any other websites similar to that. Not off the top of my head, anyways. I don't remember ever seeing any others. But it's really fun, it's almost akin to back in the day when when I would go to Radio Shack. I don't know, maybe you did too, but and just rummaging through the drawers and seeing what weird things they had, and it was like you could go in there without a single clue as to what kind of project you wanted to build, and you could just find the weirdest stuff and be like, oh, I could do XYZ with this, or whatever. And that's what Electronic Goldmine reminds me of. I get the same vibes. I go there and just scroll, and it's like, oh, I could do so much with this or that, or I bet I could make a cool video with this. And I just can't think of any other websites that offer that same kind of thing. But there must be. There's no way that they're the only ones in the world. So leave me a comment. Let me know if you know of any. There's a cool store here in Mass. You Do It, I'm pretty sure. It's DIY, You Do It Electronics. I can't remember. They're up near Norwood, but they're kind of like Radio Shack used to be. But it's a bit of a hike, so I don't go there often. Oh, excuse me. So, what goes here? The battery. I keep forgetting the gauge on these wires is so tiny. I was expecting bigger. No, that should be well for the flexibility, and it won't matter. These aren't silicone. They're so tiny, they flex great. Get some more flux going here. Oh, not nearly enough solder, huh? Yeah, those are some big holes. That's kind of weird that they drilled those holes so big for these little, it's like 26 gauge wire, whatever this is. Well, nah. Nah, we're just sticking with it. I'm gonna use this the connector that came with it. Wouldn't want to stray too far from the path. Lord knows what might happen. Yeah, so I don't want to give too much away, but this video that I've been working on with the inverter I brought out earlier, this the place I work at, it's a it's an independent auto dealer, but also we do a lot of custom installations. And this inverter came back. It was a year or more old, and it came back with a fault code that I think it's an overload code. Yeah, it was an overload code, and so we replaced it because it's the more reliable thing to do is just replace it instead of trying to repair it and giving the customer a repaired item. Because the other components are worn out. So if you replace just one bad component, now the rest of the device is still old, and it's better from a business standpoint to just give them something new. So that's what we did, and I got the old bad one. So I started filming, trying to figure out what's wrong with it, and I use my mechanic's stethoscope. If you know what that is, it's a long metal rod with a diaphragm on the end, so you can listen to like bearing vibrations and stuff. And I use that to poke all the different MOSFETs to try and hear because there's arcing going on inside. So I touch each one while it's shorting out, trying to figure out which one it is. So I ended up I don't actually know because I have to desolder them to test them. I tried testing them in circuit and it's not working right. So I have to desolder them to test them. But I'm pretty sure that I narrowed it down to one of the MOSFETs and I found replacements. So hopefully when those come in, I can finish that video up. Alright, so we got this whole thing all soldered up now. All we're missing is the little wand that goes through the maze and I forgot the camera's so close, and the maze itself. I'm not sure what the best. Let's see what the instructions say. I'm not sure what the best way to bend this up is. My impulse is to solder one end in and then do some bending and solder the other end in. But maybe I should bend it first. Install the solid metal wire course through the metal wand loop. Oh, I see. Yeah. Put the heat shrink on it before you solder it. Oh, they don't even say anything about. Oh, there we go. I see. Yes, use the solid metal wire to make the wand. So they want. Ah, okay. I thought this was a little too long. So what they want. This is both the maze and the little wand. Look at these little baby pliers. I was trying to look for I have special pliers with round jaws on them specifically. Make sure that's a good diameter, specifically for bending wire, but couldn't find them. So I'm using these ones. And oh yeah, do they supply a picture of what it looks like? Oh, they do. Yes, and this one. So just solder the. Oh, that's right. Yeah, where is my? I brought this out earlier too. I'm using, instead of the wire they supplied, I'm using this super fine silicone wire. So we're gonna solder that to this copper loop, and then we'll make the maze. But first, I'm having a hard time forming this the way I want it. Yeah, good. I think I should make sure I'm in camera, but turn this out in the back here. Eh. Yeah, but now it's facing the wrong way. Eh. That turned out all right. Good enough. Oh yeah, what? See, I was making. I just realized I'm making it too small. Just imagine, it's not supposed to touch, so it's gonna be, well, it's pretty good, I think. And it's adjustable. How about that? Yeah, there we go. I won't. I was thinking in my head I was gonna solder these together, but I'll leave them apart, and then it's adjustable, so you can increase the challenge. All right. So, how long do I want this? Pretty long. How long do I want this? Well, I want you to be able to hold it, so. Because you need something stiff. This wire isn't anything, so. Maybe something like this. I'll cut it right there. And so if I do that, yeah, that'll be plenty long enough. Okay. Enough. So, I have, oops. It's an automatic shut off. Alright. I got a couple different soldering irons here, so I don't have to stop for 20 minutes and change tips. I can just grab the other one. And, oh, I keep forgetting. Getting focus, yeah. So, let's get this horizontal. I think I'm going to solder up there. Of course, it's all just going to run to the bottom as soon as it gets hot. But so I do have a little torch to help me out with heating up the copper wire in case sometimes when you get thicker solid core wire, it's kind of hard to get the whole thing up to temperature without damaging other stuff. So I got a little torch. If I need to preheat the copper wire, that's what we'll do. Yeah. Let me fold this. I think I'll just solder it right to the side. So. Oh, whoops. Oh, that talking, I had the wrong tip on this thing. Oh well. I'm going for it anyways. That should be plenty. Okay. Let's get that in there. Oh, what, you know what I should have done? I don't know why I put the wire in there now. Yeah. Yeah, well, nah, I'm gonna preheat it. Hesitation. Get this thing glowing. Nah, not really. I'll get it warmed up though. Yes, there we go. It's like we're brazen. Alright. A little more. Oh, never mind, I got plenty of solder. So what I was gonna say is first I should have soldered a blob to the side of the wire, to the side of the copper. Is this not? I don't know if it. There we go. Take a minute to react. All kinds of mistakes going on. Yeah, let me hit that back up again when my soldering iron warms up. Had the temperature set too low, and I got the wrong tip. It's a disaster zone. You know what? Why don't I just where's the end of this? There we go. Yeah. instead of screwing around with the soldering iron, I should have just done that, huh? Alright, so anyways. So let's see how long I want to make this. I'm going to say something like that. Oh, that. And it goes into that pad right there. So I'm going to do the same thing, double it over. A little extra thickness. All right. Oh, yeah. Yeah. I'm wondering if I didn't make this lead for the wand a little too... Oh, it's a pretty big pad. I'll use this one. I'm wondering if I didn't make the lead to that wand a little too big. Too long, I mean. Too big. It's a silly way to say that. Yeah, so back to this. Oh. Oh, I made the classic mistake of forgetting to put the heat shrink on. Oh no. Oh well. I got some, or I could, well, I don't know what's best. I'm gonna say bend that straight and slide the heat shrink over. And now this is another interesting little quandary here. This wire is too large of a diameter for the holes on the board. And they don't mention to use the solid metal wire, bend it, install it, and then test the kit. Oh, I forgot to mute my phone. So, I think the direction I'm gonna go is, instead of trying to make the wire smaller, I'm gonna make the holes bigger. I'm gonna get my drill. Tried to be prepared, but they threw me a curveball. Let's see. Oh, I don't have my calipers with me, but I can just eyeball it. That'll be too big. That'll be too big. Maybe just a hair bigger. Oh yeah, I keep forgetting the camera's up here. Size and drill bits. I think that's gonna be too big. And this one down here. It'll be a hair too big. So the problem is, I'm sure this wire isn't. These are all American Standard drill bits. So my good metric ones are at home, at work. All right. So when I'm drilling through the PCB, I'm gonna go from the copper side back, because if I go from this side towards the copper, there's a chance I could push the copper right off of the board. And I'll just go nice and slow. Yeah, I don't have my files or sandpaper or anything, but oh well. Just to double check. Oh yeah. If anything, she's too big or too much. Oh well. Yeah, don't want to bring that in. So, where is... Oh well. Now for this one, I'm definitely going to be needing to preheat the copper. But, oh yeah, you know what? This is silly long. I don't know why I made it that long. Oh well. Let's not worry about that now. Yeah, I think I'm going to solder one end and then do the bending before I solder the other end. And I was thinking originally I was going to put an L in it and solder it to the pad sideways. Let's see how does that look in real life. Feed it through all the way. All the way with LBJ. There we go. And I'm just going to absolutely drench this poor thing. About $20 worth of flux. Turn the no clean flux into clean. You know, there's a joke there. I just can't think of it. Let me get this in the advantageous position because this thing's going to be way too hot for me to be holding. Get my solder out of here. I need this clip. Whoop, almost fell through on me. There we go. Let's put my giant head in front of the camera. Okay, so back to the torch. I don't want to melt the flux right away. Maybe I'll heat the wire a few inches down. Copper's pretty conductive. I'm sure it'll get plenty hot up at the top. Oh yeah, there she goes. So the flux is running down. Whew, flux is running down the board. Good thing I got my extractor fan going. Oh, and I guess my soldering iron went back into standby mode, so that's convenient. Yeah. There we go. She's a quick starter. Oh, and the wire has completely popped out of the board. It's a disaster. Alright, just get a little bit there. I think I'm gonna go right back to, how about we just solder it with the torch instead of messing around with the soldering iron. Yeah. It's hard because trying not to destroy this circuit board. Oh. Ah. There we go. Oh yeah, did I mention I got my extractor fan over here? I don't know if I mentioned that. Definitely don't want to be breathing these tubes in. Tubes? Fumes. You don't want to be breathing these fumes in. Alright, let's evaluate the damage. Yeah, she's fine. Beautiful. Alright, oh yeah, you can see the flux is way up the board. That's another thing. I got my, I couldn't find my regular alcohol, so I ended up, I got my I got tubes on the mind. I got my tin of denatured alcohol. This is, I'll do the same thing. Go ahead and give this a quick little wipe down. Oops. And I do have a toothbrush, but that's for the end. Right now I'm just giving it a quick little bath. There we go. Oh yeah. No, it doesn't want to focus, huh? No way. For some reason when I'm live streaming, these cameras never want to focus. Yeah. Anyways, so now is the fun part. Oh yeah. Well, actually, here's the not so fun part. I gotta fix my mistake where I forgot to put heat shrink over this. Here's the heat shrink that they supply, but I believe this is weird. Is this? Where's the other? That would be strange if they gave me 2 pieces of heat shrink. There must be a third one. Well, yeah, I'm just gonna Sorry, I had to think there for a second. I'm just gonna go ahead and move on with putting this heat shrink on there. No dice, huh? Listen, I'm not desoldering that wire. You think I am, you don't know me. That heat shrink's going on there, one way or another. Yeah. Why am I doing this? I don't know, honestly. Because I can. Nah, it's because I made this a little bit longer than I want, so I'm just trying to take up some wire. Same thing with this tube. This is how short do I want to cut this tube? And how do I not have scissors? Oh, okay. Should have done this first, but that's all right. So we're gonna, actually, I'm gonna leave it its full length, and that'll give some strain protection to the wire. Let's go ahead and wiggle this thing on here. Let's see, I need something. I don't know why I didn't just go for this in the first place. There you go. Now, how far? This bends around to like right there, I believe. So we'll go ahead and clamp this. Get the heat gun out. Let that be a warning to anybody with headphones. About to bust out the industrial hairdryer. This is some high temp heat shrink, I gotta say. It's usually shrunken by now. Huh. Well, I think I'm gonna call it there. You know, it's not completely shrunken. Try not to burn myself or put fingerprints on this. It is very rubbery. This is an interesting style of heat shrink. I only use glue line stuff, really, almost exclusively. I don't think I've ever used. Look how thick. I don't know if you. Oh, man, that whole time. I don't know if you can see how thick this is, but it's way thicker than normal heat shrink. I had a tube of normal heat shrink. Oh, here it is. Oh, well, you can tell. This camera just doesn't want to focus. But this is normal heat shrink up here, and it's got a wall thickness more like paper. And this is the wall thickness on this stuff is like 3 times as thick as the wall of a straw. Kind of crazy. Anyways, it's enough rambling about heat shrink. Oh, I missed Dervis from Turkey, huh? It's hard to tell. Your flags are so tiny in the chat, but hello to Turkey. All my Turkish viewers. Hope I'm not boring you guys too bad. Alright, so I made the loop a little bit bigger. I think that'll be a little more fun. We don't want this thing to be too difficult. And I think, afterwards, not on the live stream, but I think later on before I gift this to my mother, I think I'm gonna put some epoxy here and get a little more strain relief on this wire. But now we're here for the fun part. We're finally here at the fun part. So if this is the fun part, I don't know what the rest of this video has been. A disaster. So anyway, so here sorry, I'm getting distracted. Apologies. Hey, anyways. Wow, it's already been an hour. Incredible. I'm feeling very uncreative right now. I don't know why. Having a hard time envisioning a cool maze for this thing. Yeah. There we go. Okay. I think that's pretty good. So I gotta put some heat shrink legs on this, put the wand inside it, and then I'll solder it to the pad. Make sure my soldering iron is actually warmed up this time. I just realized, right, and I totally forgot I had mentioned this a few minutes ago. I had 2 pieces of heat shrink and now I only have 1. Excuse me. My project is ruined. Nah, I'm kidding, it's fine. So I'm gonna go ahead and put the legs on here. Oh yeah, man, I'm bad at this whole camera etiquette thing. So let's pop this. Oh, I'm now realizing I probably should have put this heat shrink on before I bent this ridiculous maze. Boy, that's the second heat shrink mistake I've made. This is in rare form today. Rare form. Alright, enough with the scrambling, please. So hopefully I'll still have 1 whole piece of heat shrink by the time I get it down there. And then I'll have to turn on the industrial hair blower again. Hair dryer, hair blower. Rare form. Probably should have spit on this thing first, huh? Alright, anyways. What was that? 30 seconds to put a piece of heat shrink on? There you go. Alright, here comes the hairdryer. Oh. Yeah, I'm gonna try one of them now. Okay, so I did the one on the end that's already been soldered. And now I gotta get the wand on there. There we go. Put that on the far end. Now, pop this in. And there's a question. Yeah, when I'm doing normal wires on projects or in the field, automotive field, usually I would slide the heat shrink back. But this is bare copper wire, so Naturally, the thing to do is to just leave it in place and just hope I can keep the temperature low enough it doesn't get damaged and it just shrinks in place like it's supposed to. So let me do a little flex in here to get this how I would like it, so I don't have to be trying to move it after it's soldered in place. I think that's pretty good, though it's kind of tending to want to pop out of the board. Let me put a little, there we go. That's its natural state. Fantastic. So let's drop this in place. Ooh. Ah. Oh, I wish I realized that at first. I could have cut a little corner out of that heat shrink so it sat down properly, but that's alright. So anyways, starting to ramble again. Some big old ramble fest. Let's get this in the jaws. Let me lift the jaws up and flip this thing over. Oh yeah, that just dawned on me too. I need this to be upside down to solder on it, and the heat shrink's gonna fall. So I'm gonna see if I can't just give it a couple licks with a lighter so it stays in place. There we go. Alright, soldering iron's on. Let's get the torches going, the flux flowing. We are almost in a position to test this thing. So, flames going, the flux is flowing. Oh, and I just blew my torch out. You know, honestly, it seems more intelligent to. But then, I just don't want the flux to be running up the heat shrink. Oh, I forgot to clean the tip of my soldering iron. Womp womp. Alright. Whole bunch of solder on there. Yeah. Gonna have to stick with the torches. Yeah, I'm trying not to. See, the problem is, usually you just heat the metal up and then take the flame away and touch the solder to the hot metal. But the problem I'm having here is that I don't want to get this thing. Oh, look at that too. I'm trying to not. I'm trying to avoid getting this thing screechingly hot because I don't want to have. Is this thing dead already? My guy. So the problem I'm having here is I'm trying to keep the temperature, at a reasonable level, but I'm also in need of a lot of heat. So let me go ahead and flip this back around here. I'm going back to the soldering iron method. Let's see how this goes. Just feed a whole bunch in there. So my torch ran out of butane, and that's why I have abandoned the torch, even though it works so well. So let's just go ahead and just start dumping loads of solder onto this thing. Obviously it's already soldered enough to work. I'm just looking at this from a structural standpoint. I want a bunch of solder holding this thing in place. And make sure, yes, there we go. Now we got some good melting through and through. Man, it came and went so fast, I didn't even realize it. Yeah, that's good. Okay. Hot, 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 hot. Oh, wrong. Releasing the wrong jaws here. There we go. Okay, so get this. I guess it doesn't really matter, does it? I think, but then the thing's upside down. Oh yeah. Maybe I should clean the flux. The no clean flux. I gotta clean my no clean. Yes. All right. So, I can't decide if I'm gonna. Yeah, I'll do that now. Fine. This has already been going for an hour. I'm trying not to bore everybody to death, but most people are gonna be watching this afterwards, so you can just skip ahead. So I do have a toothbrush. I'm just trying to give this a nice quick little polish. It's no clean flux. I'm not worried about leaving it on the board. I just want to clean up the big old globules so there's no like wet spots, lumps of flux just hanging out. Oh yeah. Apologies on my camera etiquette. Like I said, I'm in a rare form today. So this is just alcohol I'm rubbing with a paper towel, kind of like a sponge. Like I said, my goal isn't to completely clean all the flux off the board. I just want to get the big stuff. And I think that goal has been accomplished. There's obviously still some film around these components, but it's not going to get people's hands soaked like mine earlier. So anyways. It's interesting. Let's just get this back over to this side. Now, you thought we were done, but we aren't. You were wrong. So, we now... Oh. This camera's just slowly, I keep knocking the camera further and further away. Alright. So, now what we're going to do is take this protective film off of just one side of the acrylic here. Or attempt to take it off. Ah. This isn't where this isn't. Oh no. This isn't working very well. Okay. Alright. Let's try this again. Oh man, this stuff does not want to come off. Wow. Alright. There we go. This is like... I don't know. I don't like it. Finally. Hey. Almost. Hey. Alright. So, now with the acrylic facing up, plop that baby down. I'm going to take some of these adhesive pads. Actually, first, how many did they give me? 1, 2, 3, 4, 5, 6, 7. That's an interesting number. Maybe they just gave me one extra for good luck. Oh, and they are also tearing like booty cheeks. Okay, so I'm going to apply these directly to the bottom of the PCB. Boy, this is just an absolute disaster, huh? And I'm going to try and keep them just a little bit inboard of the edge so that they're not like, these hideous things jutting out from under the circuit board. And we'll just go ahead and put one in each corner. And additionally, probably put 2 in the middle. And that 7th one, I'll just hang on to that as a good luck charm. Well, this has gone very different from how I expected. You know, when I first was thinking about doing a kit live stream today, I was like, oh, I have that one kit I need to make for Mother's Day. This is that's a really simple one. It won't take me long. I can just do a quick little live stream. I won't have to edit any video. it's been like where's the timer? It's been an hour and 10 minutes. Yikes. Oh well. Sometimes I enjoy watching this type of content, so I'm sure there's other people out there that enjoy it too. Just kind of hanging out, not really doing much of anything. Usually I'll watch this kind of stuff doing dishes and driving, or if I'm just doing a lot of computer work, I'll have this going on the side. That kind of stuff. So, there's our 6 pads. Here's the 7th one for good luck. Now, I kind of took that film off a little too early because I forgot the camera doesn't like to focus. Oh, there's my face. There's the camera. So, oh man, I'm thinking of too many things at the same time. I took the film off too early. So as you can see, we get some dust on the surface now. Definitely got to get rid of that. I don't have any lint-free rags with me. Although I could, if this doesn't work, I do have some coffee filters over there. I just hate to have to get up. I think that's enough. Yeah, it's not perfect, but it's also totally fine. Now, time to peel the other side of these pads off. Oh, very carefully. Carefulling. Wouldn't want to decentralize the pad from the back of the PCB. That would be an absolute tragedy. Whoa, alright. Now, here's the hard part. You know, usually on important projects, I have a caliper to measure the width and, do some quick maths, make a couple marks, get the thing centered. I'm just using my iometer today, and I think right about there. Whoa. Oh. I'm such a fool. I'm such a foolish little fool. Oh, what a fool. So, oh, oh no, oh no, oh no. So, man. So I think, let me just see if I'm correct. I don't see any of the, no, alright, maybe that isn't what happened. Oh, wait. Yep, there it is. Okay, so, remember how I was like, oh wait, no, that isn't what happened. Never mind. Alright, I don't know. I'm hurting myself in confusion here, but what I should have done was grind down that. I'm gonna have to attach this at a later date. So what I should have done was grind this down before I tried adhering it to the acrylic. So that was a big old waste of time in adhesive products, but that's all right. So what I'm gonna do off stream after we test this thing, but before I give it to my mother, I'm gonna, well, alright, so first of all, I'm going to grind these down, obviously. I might even grind the rest of these down as well. I don't know. I'm undecided. But ultimately, what I'm going to do is take some of my favorite epoxy. If you've watched any of my videos, you know about my favorite epoxy. It's the 3M through hole, marine grade, fast cure. Fantastic stuff. Waterproof. Once it cures, it's totally waterproof. It's used for like affixing, like say you're mounting a cleat to a deck and you got to drill the holes for the bolts. Well, you just put just like RTV, except it's epoxy, and you put it around, slap the cleat on, and then you wouldn't even have to bolt the cleat. This stuff is wicked strong, but obviously bolts are stronger, so you still bolt the cleat. But then it becomes waterproof, and using it in non-marine grade applications like I do when I build things, it just works fantastic. So, so, so that was one hell of a ramble. So, anyways, that's what I'm gonna use after I grind. I keep going off camera. After I grind down these, I'm gonna put some of that epoxy around the outer edge of this PCB and affix it to the acrylic that way. So, now that you know what my plans are, I'll have to kill you. No, I can't. So, now that you know what my plans are, we can start wrapping things up because this video has gone on for a little too long. So, let's bring this in. Oh, alright, let me clamp it first. Clamp, 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 clamp. And now we're gonna, get the angle. Oh, it's a disaster. Oh, it's a disaster. There we go. Oh man. Alright, there we go. So, this is gonna be very difficult for me to do with the camera so close. Let me. Oh, it's a disaster. Alright, so let me get a 9 volt. Remember I was talking about how prepared I am and I didn't have my drill or the 9 volt and all this other stuff. Alright, let's give it a test. Oh no. Nah, the switch is off. Let's give it a test. Interesting. So it's latching. I didn't realize. I thought that was just a transistor. What does it say? Oh, SCRQ1. Wow. Interesting. So it's like a set of it's like a rectifier in SCR. And so basically that's just how it's like a latching. It's like a Darlington pair or latching set of relays. Same. Well, not really. It's very different, but it's the same. The outcome is the same, is what I'm trying to say. So, anyways, da-da-da-da, ba-da-da-da. Oh, I'm gonna have to install a quick reset button. This should get irritating. All right, let me get my wire out of the way. All right, I'm gonna give it an earnest try here. This is so much harder than I thought it would be. Honestly, I'm honestly trying. I can't even talk. I gotta concentrate so bad, and I'm cheating too because I'm running my finger along the wire to try and steady it. Man, this is way more difficult than I thought. You know what would be interesting? Wow, was my finger? That was weird. I wonder how much current runs through this. Yeah, this is so much harder than I thought. If I knew, I never would have put a loop-de-loop in this thing. Ah, man. This thing is so difficult. I almost want to now. As soon as I started talking, this thing is so. Ah! All right. This thing is so difficult now. I want to create a dispenser so that if you, oh, man, I want to create a dispenser so so that if you make it all the way, holy, so that if you make it, I want to create. It's so difficult. It makes me want to make a dispenser so that if you can make it all the way to the end, you like win something. You know? I wish I had more time. That's actually, speaking of that, that is actually another video idea that I've had for a long time. Back in the day, like 2013, 2014, I built this vending machine prototype that only worked off of relays. So it was a bunch of relays, some of them latching, some of them not. Ooh. And basically the way it works is the coin track. It only took coins, and there was two switches, right, going down the track. And what would happen was to get the relays to latch and allow you to dispense something, you needed to activate the second switch, then the first switch, which meant you had to roll two coins. So you roll one coin, first switch hits, nothing happens. You hit the second switch, and the first relay turns on and powers itself. And then when you drop the second coin, the first switch allows the second relay to latch with the first one, and then you can go down and select something. And the way it worked is when you push the select button, the solenoid went in, and when the solenoid bottomed out, there were contacts that unlatched the relays, and then the solenoid immediately popped back up, so only one item would fall out. So there was no logic, well, there's logic, but it's relay level logic, which is a fun project. So that's something else I'm working on. I just got reminded of that, talking about making a dispenser for this thing. But anyways, so real quick before I end this stream, I'm curious, so maybe it would be a good idea for a short. Nah, real quick before I end the stream, let me run back down to my office and get a resistor. Wow, well, today is just something else. I can't. I have like a book of set resistor values, 1 ohm to up to a few mega ohms. So when I'm doing testing, I can just grab a specific resistor. What I wanted to do real quick was see at what resistance this thing gets set off. That just is something interesting to me. So here's a 12K. I'm going to touch it to the rail and bring the wand up. Ah, even 12K is enough. So I could put, that's interesting. 12K, huh? Let's try a 4.7 mega ohms. Let's crank it up a notch, huh? No, obviously that's way too much. 12K, what are these? 10K, we gotta go up from 12. I already did the 4.7. Alright, you know what? I'm not gonna waste any more of your time. There it is. We built it. It took an hour and a half. My regards. Been in rare form today. Lots of stumbling, lots of ums and ahs, but we got it done. And yeah, so I hope somebody enjoyed it anyways, and we'll we'll see you next time. Hopefully I'll get that inverter fixed. That'll be the first video coming out after this. And then, like I said, there's all kinds of projects. I don't know what direction I'm going to go. But regardless, I'll put out something. And we'll see you next time.